Okay, question number 3, what could the equation of this parabola be? There are lots of different possibilities. So I did put answers may vary because that's usually what a textbook would say, but I want to clarify that or quantify that. In terms of values, I know that the y-coordinate of the vertex would have to be a positive value, so my k here has to be positive. I also know that the x-coordinate of my vertex, if I follow this down, is also in the positive side. So that means I'm going to have x minus and then the value that I want to have here for h. So x take away, and then the h would actually be a positive value as well. Now, the other thing that you need to make sure is that because this parabola opens down, we need to make sure that the a value is some kind of a negative value. And another thing that you want to check and make sure is that your parabola will pass through that origin point, the point 0, 0. So once you come up with your equation, you could pick whatever you want for your h and your k, as long as your h is in the positive and your k is up in the positive as well. To get to that vertex, you could pick or tell it that it's going to pass through the point 0, 0 and sub that in for the x and the y. And then you could solve for a, and it should turn out to be a negative value. And that will then force that a to match up to make that point, or that parabola pass through the point 0, 0, like you were doing yesterday when you were solving for the equations. All right, speaking of solving for equations, example number 4, the parabola has a vertex of -1, 5. So in terms of vertex form, we have x take away h all squared plus k. The h value will be -1, so when we sub that in, we're going to have x take away a -1, which really becomes +1 squared, and then we have our +5 for the k. And it has to open down. So the only other piece of information that we know is that the a value could be any negative value. So as long as it's negative, it will work. So you can put whatever you want in for the numerical value. You could just leave it at a negative as -1, or you could take it to whatever other value. As long as it's a negative, you're good. Okay, example number. All right, for this question, it's very open-ended. The skydiver jumps out of an airplane, and his height compared to the time since he jumped is modeled by a quadratic function. What could be an equation to model his height compared to time? So we know at time 0 he's in the airplane, and then he jumps. And if you know a little bit about physics or some science stuff, you know that as you head towards the Earth, you start to speed up. You gain momentum. So that is what my parabola would look like. This spot right here will probably be where the vertex of my parabola is. Okay, so right on the h-axis. So my maximum should happen probably when time is 0. And then your height, you could do some research and find at what height people would actually jump out of an airplane. Okay, and then in terms of an a value, we know it has to be negative. And another thing, at some point, he probably will pull his parachute, I'm hoping, and it will actually deploy, and that's going to slow him down. So the parabola is actually only good for a very short period of time, and after that, then it gets into a more linear function because it's going to slow him down, and then he's going to fall to the earth at a less quick pace, hopefully, and not hurt himself. So do a little bit of research on that. You might also want to find what is acceleration due to gravity. You'll notice that most of the things that are talking about your speed or your acceleration due to gravity, when you're working with something falling towards the earth, we often have an a value of about -5. It's -4.9-ish. So they often round it to about -5. So if you do some research on that, you should end up with this value should be close to -5, at least for the first part of his fall. Your t value, you're going to have a t minus 0, and then plus, and then from whatever height that person is jumping from. Okay, my second example 5, a parabola has a vertex of -1, 5 and passes through this point. Determine the equation of the parabola. So we did these questions yesterday. We know that y is equal to the a, and then we have x minus the x-coordinate of the vertex. So x take away -1 will be +1 all squared, and then +5 for the y-coordinate of the vertex, and it passes through the point -4 and -13. That's your x and your y. So we're going to have -13 being equal to a sorry, I've got a bit of the sniffles tonight for some reason. And we put that in here. And then we get negative 3 all squared, and then a plus 5 on the end. So then we would have negative 13 is equal to a times 9 plus 5. We're going to subtract 5 from both sides to undo the 5. Oops, that was supposed to be a subtract. Subtract 5. And then we're going to get, that would be negative 18 equals 9a. Divide both sides by 9. And our a is equal to negative 2. So therefore the equation is y equals negative 2 bracket, and we go back to our x plus 1 squared plus 5.